hope you're all doing well. For this part of the video, or this part of the unit, you need your book, and I need you to turn to page 174. So if you don't have your book out, just pause the video and then come back. So if you look at your book, just very quickly, you see a chart or a graph on page 174, and if you turn the page to page 176, you see a different kind of graph. We're just going to talk a little bit about the difference between these kinds of graphs, how we use them, how we read them, and then you're going to do some exercises. I'm going to ask you to pause the video to do the exercises and then come back to check your answers with me on the video. Obviously, I can't check this, but it's a big waste of your time if you don't do it that way, so try to do it that way. Okay, so the first graph that you see on page 174 is called a bar graph. So it's this one, it's this one right here. And one of the ways that bar graphs are usually used is to compare quantities, to compare how much or how many of something. So the first thing you always need to do with a graph or chart is to make sure you understand the title. Like, what are they measuring? What are they showing to you? This title says, patients who received organs in a 1-year period. So that 1-year period tells you they're not comparing time, like what happened at different times. They're just looking at this 1-year period of time. And they're comparing something, we don't know what yet, in these patients who received an organ by transplant. Then we see the two colors. We see orange and the blue. And if you look over on the right, it explains what the colors signify, what they mean. The blue is a living donor. The orange is a deceased donor. Deceased is a word that means the same thing as dead. It's often a little more polite, and it's often used in a medical context, that word deceased. So there we know what the various colors stand for, and now we need to look at the two axes. The axis that goes up and down on the left says number of organ transplants. So how many transplants were done, all right? And we start with 50 at the bottom and all the way up to 15,000 at the top. Then you can see here the other thing they're measuring along the horizontal, the line that goes across like this at the bottom, age of organ recipients. So I think you can figure out a recipient is someone who receives an organ. So one thing you can see here is they're not looking at all at who gives the organs. They're just looking at who gets them. And we can see the age groups down from birth to 5 years and all the way up to 65 and older. And you can see those comparisons. So I want you to look at those, think about why these numbers are so different for the various age groups. Just sort of come up with some ideas about why that is. And now what I want you to do is to pause the video and do the questions on page 175, questions numbers 1 through 4. Then start the video up again. I'm also going to pause it, and then we'll talk about your answers. So pause the video now. Okay, welcome back. Let's see how you did. I think the number one was pretty easy. Where did the majority of donated organs come from? You're just comparing the orange and the blue. You can do that in 1 second by just looking at the colors, and clearly more organs came from deceased donors, letter B. Okay. In number 2, which people underwent the largest number of organ transplants? You can also see that very, very easily on the chart, and the answer would be letter C, people 55 years and older. Okay, now, the next question, the key is the word might. They're asking you to come up with an idea. They're not saying that you absolutely know this for a fact, but why might so many people 50 to 64 years of old get transplants. What do you think? So here are some possible reasons. Maybe you came up with other ones. One is we get sicker as we get older, right? So as we age, we get more diseases and we might need more organs. Maybe we have more money at that age or better health insurance, which would allow us to get the organ so we can afford it. Another idea is if we're thinking about living donors, at that age, we have, many of us, not all of us, have more children, nieces, nephews who are strong and healthy and might be able to donate an organ to us. So those are three ideas about why that might go up. But then look at number 4, they're asking, again with the word might, like what's your idea? Why would the number of transplants decrease or go down for people 65 and older? Okay, so a big reason is that even though people that age, my age, might need an organ, they might have other illnesses that come with age that would make it not a good, would make their chance of surviving an organ transplant not so good, so they wouldn't get the organ. The other thing is that, as people get older and you're, into your 70s, 80s, you don't want to maybe take an organ from somebody that's in your family because you don't want to put them at risk. So those are two big reasons why that goes down. The other thing is sometimes people die of other things while they're waiting for an organ transplant. So those are all some possibilities. So that word might is an important one when you write an answer, when you're giving an idea, but you don't actually know the actual answer. Okay, so now take a look at the other graph that we talked about on page 176. And you can see this graph looks completely different. This is a line graph. And most of the time, line graphs are used to show a change over time. And you can see that by looking at the bottom of the graph. We start off with 1991, we end up with 2015. So clearly we're looking at how things change over time. Now, looking at the title of the graph, organ transplants, donors, and people on the waiting list. So there are 3 groups that they're comparing, so you can see 3 lines, right? And we have them by color again. The black is waiting list, the blue is transplants, and the orange is donors. We can look along the vertical, the up, oops, my hand isn't in the picture, the up and down axis, and we see numbers, right? Starting with 0 and going up to 130,000. Now this graph makes this easier to read because you can see individual numbers. Not all graphs have that. Some graphs you just have to go to these numbers, like slide your finger along to see what the number is, but they made it easier for you. So if you look at this right away, you can see that this represents a problem. Okay, think about that problem, turn off the video and do page 176, and it continues 177, number 5 is up there, or number 4 continues up there too. Press pause and then we'll go over the answers. Okay, so number 1 was pretty easy, but you have to look at 2 different lines. The answer is A, the number of donors you have to look at just one line here, The number of donors increased, then decreased, right? So we see that small change going up and then going down. We're just looking at one line there, the number of donors, the orange line. 2, during which years did the number of people on the waiting list increase the greatest? There you have to compare, and it would be A, between 1991 and 2000. So if you think about the slope of a line, like going up like this versus going up like this, that's where we're seeing a small change or a big change. 3, during which years did the number of organ donors decrease? And that was between 2010 and 2015, which is surprising to me that it was going down. And why does there appear to be a decline in those years? The second part of number 3. The answer is probably that it's tricky, but that the number of donors decreased even though the transplants increased because doctors figured out how to use many organs from one donor. So as time went on, they could take one donor and use maybe 5 or 6 organs, whereas they couldn't do that before. The next part, number 4, what can you infer from the information? This is tricky, and remember, inferences, you don't have all of the information, but you're making a conclusion, and the answers would be B as in boy, D as in dog, and F as in frog. Number 5, how do you account for the difference between donors and transplants in any given year? That goes back to that same issue that one donor can give many, can lead to quite a few transplants into different people. So we'll stop there. That's kind of an introduction to graphs and charts. Most important thing is in your textbooks, in other classes, don't skip the graphs and charts. Look at them in this same kind of detailed way. Okay, continue on with the module.